let's get started. We are doing exponents. The only topic left is number patterns, and then we are revising term 1. Guys, can you believe term 1 is nearly over? I actually cannot believe it. Like, I'm blown away, okay?
Yeah.
I'm freaking out because of where I teach. I don't know if my learners, they're over me. They're just like, man, we're over it. 1% to end. But I'm just like, no, guys, I want you more. I want to talk to you some more. I'm kidding. See, everyone's just like, I can't wait. Guys, you can't be so excited for someone to end. Come on now. But it's fine.
Certain papers, marking, and all those things.
Oh, don't remind me. There's going to be marking stuff, but it's fine. We're not talking about that now. Okay, today we are talking about negative exponents. Okay, so before we talk about them, okay, I want to ask you guys, laws of exponents. Let's talk about when we divide these two. So here we have an x to the exponent of 5 divided by x to the exponent of 3. How would you solve this according to your laws of exponents? I know you've done this. I just want to see that you guys remember this. And Tabi saying, I see Otepi in the chat has given us an idea. And Tabi saying, minus the exponents. When we divide, we minus the exponents. 5 minus 3. Everyone seems to agree with this. Okay. So we would say x, the exponents of 5 minus 3, and ultimately that will give us x squared. Okay, so you guys understand this rule, right? Now my question is, what happens if we have to the x, let's go with 5. Let's use the same numbers. Okay, we follow the same rules here, right? So we would say x to the exponent of 3 minus 5, and how much would that be? Tell me what the final answer is. I see participants' hands are raised. And Tabi saying, are you unmuting? Are you speaking to me? I love speaking to you guys.
So what you would do is you'd minus the exponents, and then when you minus the exponents, it would give you -2. And then to make it a positive, then you would like take the -2 and put it over 1, and then you take the over 1. You'd put the 1 on top and take the x over 2 as the denominator.
Okay. Thank you very much. Isn't Tabi saying your name? I wonder. We shall never know the wonders of the world. Okay. So what he said to us is, since this is over 1, we are going to move this to the denominator and make it positive. My question is, do we know why we do that? Why does that make sense? Where does that come from? Okay, let us solve this in expanded form. Okay, so if I have, our original question was x5 over x to exponent of 3, right? This would be the same as x times x times x times x times x 5 times, right? That's tiring. All over x times x times x 3 times, right? So all we have here is multiplication and division. So we can, it's called canceling out, I don't like that word, but we can cancel them and they divide into each other. So x goes into itself once, and there once, done. There once, there once, done. Oh wait, I swapped them around, am I? No, I'm right. Then there once, done, right? And then what's left on the numerator? It's 2 x's, which is the same as x squared. So that's where that law comes from, right? And if we're doing it the other way around, the rules do not change. Everyone says because we can't have a negative exponent on top. Yes, we don't want a negative exponent, right? It is inconvenient. So since we all seem to understand that law, it works the same way around, right? So if I have x cubed over x 6 equals, so you have 3 of them in the numerator, 4 over 1, 2, 3, 4, 5, 6 equals once, 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 once. What is left in the numerator? What's 1 times 1 times 1? Tell me in the chat. 1 times 1 times 1 is 1, right? But in our denominator, we still have, what do we still have left? We still have 3 x's that are chilling there. Do you see that? So we still have 3 x's that are chilling there. That's not 3x. 3x would be x plus x plus x. Remember, we're multiplying. So tell me what's x times x times x. How can we write that? Rewrite that in shorthand. 1x? No. X cubed. Thank you. So this will be the same as x cubed. Do we see that? So do you agree that if we did method 2, which would be x 3 minus 6, this would have given us x to the negative 3. But we have just proven now that x to the negative 3 is the same as 1 over x cubed. I hope we understand this, okay? Shouldn't be complicated. Yes, it's easy to just tell you, move it to the denominator to the numerator. It's very easy to tell you that, okay? But you deserve to know why. Why does it work? Okay, I hope I am with you guys. Okay, let's talk about, before we even start, the reason it's down there is so it becomes positive. Yes, ma'am. Pumzile, let's hear what you have to say. Hello.
Hi, ma'am.
Yes, ma'am. Do you have a question? Pumzile vanished. What happened? Did you mute yourself? There we go.
Ma'am, may you please go back to the methods? I just want to screenshot quickly. Just give me 10 seconds.
Okay. Okay, sorry. I was too fast. There we go.
Thank you, ma'am.
You're welcome. Okay, guys. So now we know why we can move variables up or down according to their exponents. So before we work with what's on the left-hand side, I want to test that you understand what I'm talking about. X to the negative 7. If I rewrite this with a positive exponent, what do I write? Tell me in the chat. How do I rewrite this using a positive exponent? Let me leave the chat there so I can see it. Anyone? Someone? -1. Akona, I'm not sure. Impulses 1 over x plus 7. Avril and Tammy agree, so that's Tiamo. So this can be written as 1 over x to the positive 7. Incredible, guys. We are understanding it. Okay. What if I have 2x negative 3? Now I'm pushing you guys a little bit. It's not too much. You can handle it. But I'm pushing you guys a little bit. What happens now? So I have a 2. I have an x and negative 3. Tammy's hand is raised. Tammy? Hi, Tammy.
Hi, ma'am.
Here we go. You have an answer for this?
Yes, ma'am. Yes, ma'am.
Yes.
So, ma'am, the answer is going to be 2 over 3 to the power of x because 2 is a whole number.
2 over
X to the power of 3.
Thank you very much. You are incredible, ma'am, and you are correct. Okay, guys, we get the point, né? Only the one with the negative exponent moves. Okay. Full fellow, you missed the explanation in the beginning of why this is true. When we look at this, okay, remember the laws of exponents say if you are dividing and you're subtracting exponents, no, when you're dividing and you have the same base, then you subtract the exponents, right? That's what we did on the right-hand side. So if you had x cubed divided by x to the exponent of 6, you would generally say, according to law number 2 of exponents, x to the exponent of 3 minus 6, which would give you negative 3, right? So then I wrote it out in expanded form. So x cubed is the same as x times x times x. X to the power of 6 is the same as x times x times x times x times x, blah, 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 all the way until 6 times. So then you divide each x into each other and you will be left with 3 x's at the bottom and 1 at the top because you divided all of the ones that were in the numerator and you were left with 1 times 1 times 1. Do you understand, fellow? So that's the logic, but I don't even think you have to know the logic in school. Okay, you just have to know that you can move them up or down. I hope I am still. There we go. Whew, you guys got quiet for a second and I was like, did I lose everyone? Whew. Okay, we understand. I have one more challenge for you guys. What happens if I have, okay, 1 over x negative 2. Then what? Don't understand why there's a line that just appeared out of nowhere. Swanelo, let's see what you have to say. Swanelo, you're welcome, Leila, and fellow. Okay, Swanelo.
Ma'am, isn't that ma'am 1 over ma'am 1 over x squared? 1 over.
Remember, let's check out these ones. These ones were all in the numerator, right?
Yes.
And we moved it to the denominator before we made the exponent positive. You see that?
Yes.
Same thing. We moved it to the denominator and we made the exponent positive. So here, if it's already in the denominator, where are we moving it?
Ma'am, is it 1 over, wait, ma'am, is it then x squared over 1?
There we go. X squared over 1, but we don't write the 1 usually, right? So that's just the same as x squared. Do you understand now, Bonello?
Yeah.
So wherever it is now, once you move it, you are making the exponent positive. Guys, think about when you are transposing, you have x plus 2 equals 0. When you move it, what happens? It becomes negative. Do you see that? It's the same concept, okay? If it's in the numerator and we are moving it down, it becomes positive. And if it's in the denominator and we are moving it up and it's negative, it becomes positive. Well done. Okay, what's the answer for the first one? Let's go back to what I have on the left now. These are gonna be too easy for you guys now. We're gonna fly through this. Okay, which law of exponents are we applying? We have x and x, we are dividing. So what law of exponent do we apply here? Tell me what the answer is. -1. People say it's -1. Where are we, Natasha? We are here. Over here. Akona. Law 2, that's correct. So our answer is what? Akona, are you there?
Hi, ma'am.
Hello.
Ma'am, you said we have two methods, right? So, ma'am, I used the one where you like, since the x are the same, we will not repeat them. I only like did one x and then I said 3 minus 4. Is it correct?
Yes, you did. It is very
Then,
correct.
ma'am,
So your
then,
final
ma'am,
answers.
my last answer, ma'am, was -1, ma'am.
To the negative 1. Okay, if
Yes.
you were rewrite this as a positive exponent, tell me what you would write.
In the exponent form, ma'am.
As a positive, remember right now we have a negative exponent, right?
Yes, ma'am. Yes,
One
ma'am.
is negative. We want it to be positive. Check on the
Yes, ma'am.
side here. How do we do that?
We turn it into a positive.
And we move it to the
Right hand to the left.
to the denominator. Remember, x negative 1 is the same as x negative 1 over 1. You see that?
Okay, ma'am. Yes, ma'am.
So we take this and we take it to the denominator. So then it's the same as 1 over x. Do you understand?
Okay. Yes, ma'am. Thank you, ma'am.
You're welcome. Thank you for talking to me, Akona. And for some reason, we have the same question again. X to the negative 1 is the same as what? Remind me again in the chat. 1 over x. Thank you, Mpo. Mpo was decades ahead of me. Before I even asked, Mpo was there waiting for me to ask that question. What about this one? How do we change x to the exponent of negative a to a positive exponent? Hand just went up. Ohuhle? Hello? Tammy says 1 over x to the a. Zet says 1 over a. I'm hoping that's a mistake. Vuyo? Ohuhle is not unmuting. Vuyo, are you there? Mpo says a. Guys, don't get rid of the base. Here. Guys, please keep up. We're over here. X to the negative a. How do you write that with a positive exponent? 1 over x to the a, 1 over x to the a.
Can you guys hear me?
Yes, I can. You know?
Can I give it a try? I'm not that good at maths, but I'm gonna try. Okay, so I did it like this. I said 1 times. I first changed all the variables to like ones. I used units. So then I took the x, I turned it into a 1, and then I said 1 times -1, and then it gave -1. Is that right? I'm not sure.
Okay. Are you doing the one with the a? This one.
Yes. I just changed the a into a 1. I also changed the x into a 1.
Yo, but that's confusing. Check how easily we can do this. We have
Okay,
x to the negative a, right?
Okay.
And it's over 1. Any number is always over 1 because a number divided by 1 is just the number itself. Do you agree?
Wait, sorry, can you say that again?
A number over 1 divided by 1 is just the number itself. So 2 over 1 is just 2. You agree with that?
Oh, yes, ma'am.
There we go. So this is over 1. Now we want to move our variable to make it have an exponent that is positive. So if it's already in the numerator, where can we move it? We can only move it to one place, which is
The denominator.
the denominator, okay? So then you're gonna be left with 1 over x to the exponent of a. You see how easy that is?
Okay, so when you move it to the denominator, it becomes a positive.
Yes, sir. And the same, let's look at the next one, okay? The next one is in, where is it?
Okay, so am I gonna do it like this? One goes to the it already looks like it's already in its perfect form. Sorry, wait, I'm gonna try again.
Mhm.
So it's the A, and it goes to the A with the -1 goes to the numerator, and then 1 goes to the denominator.
Thank you very much.
Did I
But
get it
remember,
right?
we're not swapping them, okay? Be careful not to say one goes to the denominator. You're just writing what's left. Okay. So
Okay.
it will be A to the 1, which you can just say is A. Do you see
A
how
to
easy
1.
it is? We're literally just moving them. Okay.
Oh, okay.
There we go. I hope you feel better. Well done. Okay, everyone, are we still with me? I saw a lot of correct answers in the chat. Guys, A over 1 is the same as A. Remember, we said 2 divided by 1 is the same as 2. So yes, it will be A over 1, but that would be the same as just saying A. Okay. So there would be our lovely definition. If you have a base to a negative exponent, you move it to the numerator or the denominator. Are we with me? I hope we are. Okay. If you are lost, now's the time to raise your hand. Be like, I don't know what's going on. Nsako's hand is up. Let's hear what Nsako has to say.
Hi, ma'am.
Hello.
Can I quickly ask for number 1 and 5, basically what I
Nsako, we
was
can't hear
X
you. Your
power
connection.
over X to the power 4. And then I said X to the power. Ma'am,
Nsako,
ma'am?
we cannot hear.
Can
There we
you-
go. Now I can hear you.
Okay. So
Restart.
basically for number 1, what I said was X to the power of 3 over X to the power of 4 equals X to the power of -1, right? Okay, so then I put the 1 in the numerator and then X to the power of X to the power of 1 on the denominator. Does that, is that wrong or is it still fine?
That is perfect, and it's exactly what we're doing. Do you see here? Check here.
Oh, okay. I didn't
You
see
see?
it. Okay. Yeah.
So we took the x that was to the -1 and we moved it to the denominator, and that's where we got our 1 over x. That is perfect, Nsako. I love it.
Okay. Thank you, ma'am.
Okay. Wonderful. It seems like most of us are understanding, so we can practice more. Let us simplify the following. Okay, example 1. Let's talk about example 1. I saw a hand shoot up. I'm hoping that hand is I want to do it with you. Let's do it together. Who have I not spoken to? Tammy. Hi, Tammy. It's your hand that just shot up. I just saw that.
Hi, ma'am.
Hello. Are we answering?
Yes, ma'am.
Let's go for it.
Okay, ma'am. So firstly, you have to use the second law. So basically what you're going to do, you're going to say x to the power of 6 minus 8. And then the answer is going to be x to the power of -2.
Okay.
And then, ma'am, the next thing you're going to do is you're going to change the negative exponent to a positive exponent. So you're going to make the x to the power of -2 a positive. So it's going to be the denominator. So you're going to say 1 over x to the power of 2.
Thank you very much. You are a superstar, rockstar. I love it. Thank you. And thank you to everyone in the chat who's also doing it. I see you guys. Hey, that was so easy. Tammy was like, I got this. I got this. Fulufelo wants to do the next one with me. I saw that hand go straight up.
Ma'am, I wanted to ask a question.
Okay, sure. Ask your question.
Okay, so when we are using the law of exponents, after we divide the powers, do we is it the same for all of the numbers when we are changing it from a negative to a positive?
Yes. So you only move the ones that are negative. Okay. What I mean
Yes.
is, if you have, let's say you have a squared b negative 3. Which one is negative there?
B to the power negative 3.
We don't want this to be there. Okay. So
Yes.
that's the one you move. So the a squared will stay in the numerator. Okay. And your b
Yes.
will go to the denominator. But when you move to the denominator, what happens to the exponent?
It becomes positive.
It becomes positive. So it will be a squared over b cubed. Do you understand?
Yes.
Did I
Thank you,
answer your
ma'am.
question?
Yes.
Wonderful. There we go. Can I zoom in a little? Is this too small? I'm assuming that's the problem. Can I zoom in a little? Guys, how do I make this big? Okay. The only thing I can think of is to actually zoom in. Okay. There we go. Okay, Natasha. I see your hand is up. Do you want to answer with me?
Hello, Miss. Can you hear me?
Yes, I can.
Okay. Hi, guys. So to start off, we are going to put exponent 1 to x, to the variable x.
There. Okay.
And then after, we have to minus the exponent since we're dividing.
So tell me what to write.
So x to the power of 1 minus x to the power of 2 is equals to x to the negative 1.
Okay, be careful. So it's x to the power of 1 minus 2, right? Not to the
Minus
power of
2.
1 x minus 2. Yeah, you get what I'm saying, but I understood what you meant.
Yes, I do.
Okay.
Okay.
And then remember
And
to do them at
then,
the same time. Try not to split your question, okay? So we've
okay.
dealt with the x's. Let's deal with the y's. So y.
And then we have y cubed minus 1 to the power of, y to the power of 5.
Okay, next. What is 1 minus 2?
Negative 1.
So we have a negative 1. And then what do we have with y?
Negative 2.
Negative 2. Great. Then what?
And then we're going to put the variables and the exponents over 1, and then we swap them.
Okay, so this is over 1. That's what you mean. Now let's swap.
Yes.
What goes to the numerator?
1.
1 over. What am I writing in the denominator?
X to the power of 1, or just x.
X and
y to the power of 2.
y squared. Thank you very much. You are
And
incredible.
Miss, I
That
have
is
a question.
correct. Yes, let's hear.
So since the sum is now over 1, isn't it we have to take 1 to the numerator and then the rest is denominators?
You only move the one that is negative. Okay, if the x was positive, then you would leave it there. That one that
Okay.
you are putting there, it's just telling you that you are making a fraction. Sorry. Okay. If that one is not there, it's the same as just saying x. But we want to emphasize the fact that we are putting it over 1 as if we are making it a exponent. Do you see?
Yes, Miss. And Miss, according to what I know, right, if you're like swapping exponents or any number, when we swap, one of the numbers has to become a negative. So doesn't one become negative because it's been swapped?
Remember, I said we're not swapping, we are moving them. Okay. We are only moving the variables, but you cannot say 0. Okay, it's not 0 that's left. For instance, if you have x to the negative 2, let's go back to our example where I had, okay, x times x over x times x times x. Okay, x goes into itself how many times?
Once.
And the same at the bottom. We've dealt with the first
Yes.
ones, right? And then
Yeah.
again, top, bottom, we've dealt with the second one. What is left in the numerator? 1 times 1 is how much?
1.
1. And in the denominator, you have a 1 times x. How much is that?
1x.
Which is just x.
X.
You see that?
Yeah.
But that is the same as saying x to the negative 1. So essentially, we are
1.
not swapping. We're not taking what was at the denominator and putting it in the numerator. We are writing what is left over. You see that? So here, we have x to the negative 1, y to the negative 2 times 1. So if you're moving all of these, what gets left at the top? It's just the 1. Do you see?
Yes, ma'am.
You're not taking the 1 that was in the denominator and putting it to the numerator. Let me do another example with you. Let's say we have 2x negative 2, y 4 all over z negative 2. Okay, which ones are moving in this new example?
A over 2. So do we have to minus the exponents first?
No, this one on the side here. Do you see here?
Oh, I saw a squared over, sorry. The ones that are moving is x to the power of negative 2 and z to the power of negative 2.
Wonderful, because they have negative exponents, right?
Yes.
Let us move them. X goes to the bottom, Z is coming to the top. What stays at the top? Let's talk about that. Does your 2 move? She has vanished. What happened?
Ma'am, please repeat.
There we go. Does your 2 move? Number 2. Are we moving 2?
Oh, no, 2 doesn't need to move.
Exactly. So we are just rewriting it. Y quad also doesn't move. But we moved our Z to the top and Z becomes positive. So it's Z squared. And we move our X to the bottom. So X becomes negative X squared. So we leave what was there and we only move what's necessary. So the 1 was already there. Okay, we didn't swap them. That's very dangerous to say. We leave what was there and we just move the ones that need to be moved. Okay, I think we deserve a brain break. Whew, my brain is exploding. And this is our brain break. Okay, we have a joke and a brain break. Let's zoom out so we can see both. There we go. Okay. Our joke says, I just saw a math teacher with a piece of graph paper. I think he must be plotting something. Guys, this is such a lame joke, but I love it. I love it. Such a lame joke. But in the meantime, you guys saw that I saw a hand shoot up, so I'm assuming you have the answer. Ken Lee, do you have the answer? Sure.
Hi,
There was-
ma'am.
Hello.
This is not anything referring to the work, basically. I have a question.
Okay.
So, basically, my question is, are we gonna like do anything like ordering and comparing common factors or something?
Common factors was all the way in chapter 1, which is whole numbers.
Oh, okay, ma'am.
So I think you should go check out the videos. Do you know how to find the videos on the website?
Yes, ma'am.
There we go. So check through that, okay?
Thank you, ma'am.
You're welcome. The rainbow is 10, maybe. Okay. It's lame, but it's still funny. Ooh, Mpo. Guys, I'm starting to feel like Mpo is in every class. Mpo, were you in the previous class? Wasn't the previous person who got it Mpo also?
Yeah. It was Mpo who got it right in the other class. Mpo.
I'm just like, Mpo, are you in 2 classes? I'm watching you, Mpo. Okay, so Mpo is correct. Okay, so one umbrella would be 5. So this in total is 10 times 4 is 40 plus 4 is 44. Okay. Excuse me. So we have established that the rainbow is 4. Follow fellow, you're gonna finish the sum for us.
Yes, ma'am.
Okay, go for it.
So I'm going to say 5 times 10, which is going to give me 50.
Where is 5 times 10? Yo, I'm so lost.
5, I think the clouds are 5.
Okay, but we have to start at the rainbows. Remember, we already know the rainbows are 4, right?
Yes.
So here we have 2 rainbows. So how much do we have? We have 8. You
Yes,
see?
8. Yes.
Yes. So times plus 8 is equal to 30. That means 2 of these clouds is 22. So how much is 1 cloud?
11.
11. Wonderful. So, okay, we said umbrella is how much? 5.
Yes.
Cloud is 11. And if we have 2 clouds, we have a
22. 22.
Which adds up, right? 22
Yes.
plus 11 is 33, plus 5 is 38.
Yes.
Now let's check what our final answer is. 5 times 11 times 8. Let's go check and see how much that is.
5 times
much is-
11 is 55.
Times
And
8.
then times 8 is gonna give me 440.
440. Thank you so much.
Yes, ma'am.
Wonderful, guys. I see your brains are breaking. Yo, I saw side eyes. What's going on? Minentle, I know. I'm also wondering, is Minentle really negative? Like, I don't understand what's going on. Guys, you guys are putting my emotions through a lot. It's can't be.
Because me, it was like, today I'm negative, tomorrow I'll be positive.
That's I'm like, is that a joke? Or are you genuinely like not feeling well? I don't understand. It can't be.
And Akon is like, the maths jokes are boring.
Akona, it's fine. We are special people here, okay? We love those. Come, fellow. Oh.
Yes. Hey, everybody.
Hello.
Hi.
Yeah, I just wanted to answer.
Oh, okay. Unfortunately, we have already answered. Umpo didn't you just give us the quick answers? Guys, Umpo is here on some sort of CSI mission. I don't understand.
That's the other Mpo.
Oh, so
yeah.
I was about to genelela you. Yo, I was about to go in.
Because that's
What's going on?
Louis.
CIA here spying over us must hate and it can't be. Come on. Whew. Paul, because when you're plotting a graph, you know when you're plotting points, but also when you're plotting, it means you're up to something. So the math teacher is plotting. Maybe they're plotting a test like me. If you were my learners, it would be
like a surprise test.
Oh, right.
Now boys getting it. My brain is not shining.
My brain is on.
That's why we give you guys a brain break, because we understand that sometimes.
That's understanding that creepy smile, and I don't know what that means. Like there's a lot going on. Ukanya is saying tense. Guys, you guys are too much for me. I can't handle this. Let's move on. You, I am good. Let's do ones that matter. Let's start with C and D. Let's talk about C and D. Okay. I'm happy, that's why. It's a very creepy smile, Justin, but it's fine. Hey.
It's shy.
You never give me. Guys, let's do the sums. Let's do the sums. If I start memeing, I will not stop, and then we'll have a problem. Okay, let's do C and D. I'm giving you guys 5 minutes, which I feel like is a lot, but 5 minutes to try both of them, and then we shall discuss them. Okay. If you still have a question, now is the time to ask it while everyone else is busy with these two. Remember, only C and D. Leave E and F alone. Tammy? Hello.
Hi, ma'am.
Yes.
Ma'am, I just wanted to give the answer, but it's fine. I'll wait for the others.
Okay. Thank you very much. Let's wait. Ma'am, may you please zoom? Is it too small? I'm starting to think the page is too small. Is that better? There we go. Is that better? Ma'am, must we simplify? Yes. Remember, we have numbers like variables. So just simplify the sums that you can see. I hope that is better. You're welcome, Leila. We are 1 minute into our 5 minutes. Let's see. Yo, of course, my pen is going to decide to be connected. Mpho is sharing traumatic memories with us. Hectic. Hectic. What a difficult. Nelissa's laughing. Nelissa is dead. Easy. Justin, please raise your hand and do it with me, please. Show us how it is done. I beg of you. Tammy's taking one.
Hello, ma'am.
Hello.
Yeah, so I'm going to do C.
Okay.
Yeah, so I said for C, I simplified 16 and 8. I divided them, and then it made 2, and then I went to M. Then I said 3 minus 4 makes -1, and then I went to N. Then I said -1 minus 1 is -2, and that's my final answer.
Okay, remember, Justin, we wanted in positive exponents. So how are we going to rewrite this with positive exponents? Our two problems are the M and N, right? You agree? So we don't move the two. You see that?
Yeah, I see.
So where do the M and N go? At the moment, they are in the numerator. Do you agree? Justin is very quiet.
I'm thinking.
We have that over 1. That's what we have at the moment. All right?
Yes.
So we're going to take the n, move it to the denominator, and the m, and move it to the denominator, because we want to change these negative exponents to positive ones. So the 2 does not move. You leave it where it is. So it's 2 over, what do I write in the denominator? The m.
Ma'am, can you please repeat that? You are a bit laggy for me.
Okay. So we have m negative 1, n negative 2. We want to move them so that they become positive exponents. Okay. Did you hear that? Am I lagging for everyone? Maybe the problem is my network.
I can hear you.
Okay, so maybe it's just the network. Okay. So if we want to move the m and n, I don't know. Let me just finish off and explain. There we go. So if we want to move the m and the n, currently they are in the numerator. So we have to move them to the denominator if we want to make these two exponents positive. Okay, so it'll be 2 over m, because it was m1. You can write the 1, you can leave it out. And the n becomes positive 2. Okay. In the chat, if you got that, let me know. I was not sure if I should keep the 2 in the numerator, so that's why I got stuck. Yes, fellow, you would move it if it had a negative exponent. So for instance, if it was 2 to the negative 1 or 2 to the negative 2, then you would move it. But at this point, you take each of these as independent variables and numbers. You get it? Someone just raised their hand. Yes, we got it. You have 5 hands, so I don't know who just raised their hands and who has a question. Okay, I'm gonna start. Ogushe. Ogushe. Okay. I don't understand number C. Oh, okay. I was about to have a more explanation. Okay, Ogushe is not saying anything. Bogan, do you have a question or an answer?
Hi, ma'am.
Hello.
Ma'am, I wanted to answer letter D.
There we go.
Okay, ma'am. So the law that is applied here is law 2, which is division. So first I worked out the variable p, in which I said p cubed minus open bracket -2 close bracket, so that I don't confuse myself with the negatives. And then I said q to the power 4 minus 5. And then p gave me p to the power positive 5, and then q gave me q to the negative 1. Since there's a negative there, I then transpose the q negative 1 to the denominator to make it positive, in which the final answer would be p to the power 5 over q.
Wonderful. That was beautifully done. Thank you very much. That is correct. And that was beautiful. You guys are getting it. You guys are getting it. You guys are getting it. Okay. I love it. I see in the chat as well. You guys are completely getting it. And I am here for it. 52. I think we have time to do more. Guys, am I just being overly ambitious? I think we can try E and F. Okay, raise your hands if you want to try E and F with me. Let's do it together. Amokelang, do you want to do one with me? Nzako just vanished. Nzako's like, I don't think so. Goodbye and so long. Kimora, does Kimora want to try one with me? No? Okay, Saneliso.
Ma'am, I actually have a question.
Oh, okay. What is your question?
For C, ma'am, I understand why everything is the way it is, but why does the whole number separate from the coefficient?
What does the whole number separate? For C,
Yes, ma'am.
you remember these are three different, I don't want to say terms essentially, but they are different. Okay, we don't know what M is, and it's not part of the two. If we were to move the whole of 2, we would have had to have brackets around it. For instance, if you have 2M to the negative 1, then you move the whole bracket to the denominator. Do you see that?
Oh, yes, I see.
But this exponent only applies for M. It is exclusive to M, basically. So we only move the one which is attached to the exponent. In this case, it happens to be the M. Do you see?
Yes, ma'am.
Okay, I hope I answered your question.
Right. Thank you, ma'am.
You're welcome. Okay, Kukhanya, do you want to do one with me? I'm telling you, for the people who wanted to take screenshots, Kukhanya's like, no. Okay, never mind. Nobody wants to do another one with me. How about I challenge you guys? Okay, I'm going to challenge you guys to do these two. And in the next lesson, this is what we're going to start with. We're going to start with these two, and I'm going to see what you guys got. Okay, so the positive is always on top, not necessarily for the fellow. The positive is always where you leave it. Let me show you an example. Okay, if I have, okay, 2 negative 2 over a negative 4. These both have negative exponents. Okay, we have a negative 4 and we have a negative 2. We don't want those. Okay, so the 2 has to move to the denominator, but the a has to move to the numerator. So in the numerator, we're going to have a quad or a2 squared 4, and in the denominator, we're going to have a 2 squared. Okay, do we all understand? Okay, Kukanya says, Kukanya will do this thing. Okay, Kukanya, come through, raise your hand so we can do one quickly before we leave. Still have some time. It's a little bit of time, but it's time.
Was it Kukanya?
Yes.
I don't think he or she is here anymore.
Okay, that's fine. Okay, guys.
But Siabonga asked to take a screenshot. I don't know which part. Siabonga.
Siabonga, tell me which part. And then in the meantime, I think everyone can just take a screenshot